This is another nice short lesson. This won't take very long, but it's about combinations. In our recent one, we looked at permutation. So what is really the difference? In the last section, we talked about order and rank. Whenever you're trying to find out how many different ways you can arrange something, where what is first and what is second, or what is in charge and then what is next in charge, when you're doing something like that, it's a permutation. Combinations, on the other hand, are only looking at groups. So if you have that group, then that is all there is. So there's no difference at all. When we're looking at a combination, it might be something of just maybe a group of people on a committee where nobody has any rank, or maybe when you're looking at throwing books in a bag and there's not going to be any particular order to that. So combinations are different in that way. When you have combinations, you're just looking at pulling some items, or maybe all of the items, from a particular group. So you might have 12 books, decide to pick up 3 of them. Or you might have, 20 people and you need 3 of them to be on a committee. So you're taking items from the same group, and every item's only going to be used once, but the order makes no difference. One of the first skills you need to do is just look at, is it a permutation or a combination? So you have to just read carefully. Every time you see a problem with a lot of words in it, that's probably the main thing we can say, is that you need to read it very carefully. Here it says that we have 6 students running for student government: president, vice president, and treasurer. The moment I see this president, vice president, and treasurer, then I know there's a ranking. And so because we have this ranking, that means automatically that this particular one, even without me reading further, is going to be a permutation. And as you read further, it talks about how they get elected, and then at the end of it, how many different outcomes are possible for the 3 positions. So position makes a difference. By contrast, then, this next one's going to be a combination. 6 people are on the Board of Supervisors for your neighborhood park, and a 3-person committee is needed to study the possibility of expanding the park. Okay, the moment I see committee, I think it's likely to be a combination, but you do want to read, because sometimes committees have officers, but there is nothing in this that tells us that. It just says how many different committees are needed. So if we're just looking at the number of committees and we're not going to have any offices to any of them, this one is a combination. Now there's a formula for calculating combinations. However, notice immediately on this bottom right, if you were able to use your calculator to do permutations, you're also going to be able to use your calculator to do combinations. But we'll work this first one according to our formula here, and then we will go and look at it on the calculator. It tells me that we've got a 3-person committee. So that's an important number. Is needed to study the ways of improving public transportation. How many committees could be formed from the 8 people on the Board of Supervisors? So this is how many we need on a committee, and this is how many we have to choose from. And if you think about it like that, then we're going to say out of how many you have, that is N. How many you need, or how many you're going to use, is your R. So in this case, if I were going to do NCR, then that one would be 8C3. Now it's also possible to write that, like we talked about with the permutations, with parentheses and 8,3, but that's not as done so much anymore. So when you look at how this plays out, then 8 goes on the top with the factorial. Then we have the difference between the 2 numbers. So 8 minus 3 is 5. And then this last one is that second number. So it's really actually pretty quick to apply that formula. It's your first number, then the difference, and then the second number on there. So if we were going to work this out without a calculator, I know that this is 8 times 7 times 6 times 5 factorial on the top, and I'm just going to stop there because that 5 factorial then will cancel with this 5 factorial on the bottom, and then 3 factorial I can just multiply out here. So my 5 factorials cancel. Then 3 times 2 is 6, so this 3 times 2 cancels with that 6, and 7 times 8 is 56. So there are 56 different committees possible from just those 8 people. Now for the calculator though, what I'm going to do is go to Math, and then over to this probability option right here. So you just can click over to it. And this third one down, see it's just below permutation, so make sure you choose the right one, but it's combinations. And now I can put in my 8, and go over and put in my 3, go over and hit enter, and I get my 56. So in general, the expectation is that you have one of these calculators that will do this. Actually, if you have a simpler calculator and it's not a graphing calculator, even if it's the TI-30X, if you will look closely on the TI-30X, there is a way to do this. There's a PRB button. So if your calculator has a PRB button, if you'll press it, and the TI-30X, just letting you know, it's kind of got a fraction key. It's about a $14 calculator or something. But under PRB, you can see that you have an option for permutations and combinations, even on a less expensive calculator. So we're not going to work them out by hand anymore. We're just going to go through these with our calculator then. First of all, it's just making sure that you identify the correct numbers and that you are choosing the right option. And I would not be surprised if they throw some permutations in with you in this section, because that's pretty typical in textbooks to make sure that you're distinguishing between them. So here we have 12 possible books. So 12 then is N. How many different collections of 4 can you take? So that's your R. So what you're going to put in is 12C4. I'm going to come back and do all 3 of these on the calculator at once. So let's just look at this next one. There's 14 standbys who hope to get a flight, but only 6 seats are available. Okay, that means 14 is how many people I have, and then 6 really is how many of those people we will get to take. So that is 14 taken 6 at a time. And again, this is a combination because they're just wanting to get on the plane. It's not who steps on the plane first. It's just get on the plane so you can take the ride. Okay, we'll go back and finish that one. You volunteer to help drive children in a charity event to the zoo, but you can only fit 8 of the 17. So this time you're going to take the 8 of the 17. Now the reason I'm pointing this out is this one, the first 2 problems, the very first number was N and the second number was R. But on this one, the information was given to you backwards. So make sure you are reading it closely so you know which one it is. So we have 17 and then C8. All right, so I'll bring up the calculator and we'll redo those. Now you can, and I'm going to do this one more time so you can see it. You can hit Math, go over to Probability, and then option 3 is for this. So then I can hit 12, go over and hit 4, and that's my first answer. I'm going to write it down in just a minute. But if you don't want to go to Math and go over, don't forget you can go up and copy and then just hit enter again. Then you can back up and edit the problem. So that's just a matter of your choice. So I can just change that to 14 and 6. And again, I'm just editing here. So this was 17 and 8. So I get 495, 3003, and 24,310. 495, 3003, and 24,310. I'm going to bring that back up and just double check my writing. Okay, 495, 3003, 24,310. Now you can use The fundamental counting principle. Don't forget that was where you take your number of choices for each option and multiply those in, and you can actually use that with combinations or permutations. What we're looking at here then is that we have two different choices we're making. We're going to make a committee that has 4 men, but additionally then it has 5 women. We have 7 women to choose from. I wish I could draw a straight line on here. And we also have 7 men. So you can see here from the colors that we actually have 2 different things going on. So the fundamental counting principle says, let's deal with your first choices and then we will deal with your second choices. So we actually have 2 different things that we're dealing with, and then we will multiply those. For the men, I need to use 4 out of these 7. So 7C4 is what I'm looking at as I make a choice for the men to put on the committee. But then in the women, I have 7C5. And the fundamental counting principle, again, is taking your choices for your first option times your choices for your second option. So we're using that, but we're also using our combinations. So I have math, probability, option 3, 7C4. And then you can go ahead and get the answer and get the other answer and multiply them. But I do believe that if you just put a times here, it's going to work. So we're going to try that. And then math, probability, option 3. And now I have 7C5, combinations of 7 taken 5 at a time. So we get 735. When you have different choices, you just want to make sure you get your numbers kind of paired up right. So here we're going to make different committees from 5 professors and 15 students, but each committee is made up of 2 professors. So here I've got the professors underlined in yellow, and then we will get our students. We have 15 students, but the committee needs to have 10 students. Again, we'll take the professors. Well, we have 5, and we'll use 2. And then times the choices for students, where we have 15, and we'll use 10. And if you had like 2 professors, 10 students, and then 3 administrators from the school, then you would just be, looking at, well, how many administrators do you have to choose from, and just go ahead and multiply that out as well. So here we have 5, 2, and 10 with 15. 5 professors, 2 of them on the committee. I had 15 students and 10 on the committee. Okay, I'm going to double check that before I move it. Yeah, 15 students, 10 on the committee. So that is 30,030. People don't typically recognize just how quickly options go up when you're dealing with something like that. And if you think that, man, that's just not even possible, you should see how big it is with permutations just by comparison. If I did the same problem with permutations, like if there was some reason order made a difference, e to the 11th, that means that we would move this decimal 11 places over that direction. So that's going to go around the 8 digits you're seeing, plus 3 more. So that 8 would be in the thousands place. 5 is in the millions place. 1 is in the billions place. 21 billion, almost 22 billion combinations if order made a difference. So it really does go down with combinations because we're dividing the groupings. So it's a little bit differently. So, that's why it's so important that you determine, should I be using permutations or combinations? Sometimes, as again, I'm saying this, sometimes the real problem isn't the math itself, it's which formula do I use? So how many 4-letter passwords can be formed from the letters A, B, C, D, E, F, G. Now, we said 4-letter passwords because passwords don't have to be a real word. But if you have to use all of the letters that are here with no repetition. This question just asks us not to solve it completely, but how would we solve it? Well, first of all, how many letters do we have? 1, 2, 3, 4, 5, 6, 7. So we have 7 letters. And even though lots and lots of passwords are really that long and longer, this problem specifically says 4 letters in a password. So we have more than we're going to use. We're not going to use them all, so it's not just a plain factorial. However, when you are doing passwords, putting an A in front of a B is very different than putting a B in front of an A. I mean, even capitalization, things like that make a difference. So what we're going to have to do then, since order makes a difference for a password, this one is a permutation. We have 7 letters and we will use 4 of them. Now this just says how would you solve the problem, so we're going to leave that one at that. 9 comedy acts, so there's an important number for me, will perform over 2 evenings. Well, that could be important. 5 of the acts, okay, 5 of the acts. So this is definitely an important number because it's 5 out of that 9. So no matter what I'm doing, 9 is how many I have, 5 is how many I'm going to use. Will perform on the first evening. How many ways can the schedule for the first evening be made? Okay, schedule. Order matters when you're making a schedule. Who's first, who's second. So since order matters, this one's also permutations. And I have 9 and we'll use 5. And we have a couple more examples just to read through. Using 15 flavors of ice cream, how many cones with 3 different flavors can you create if it's important to you which flavor goes on the top, middle, and bottom? Top, middle, and bottom is order, so that's got to be permutations. I had 15 flavors and I'm using 3. Baskin-Robbins offers 31 flavors. One of its menu items is a bowl consisting of 3 scoops of ice cream, each a different flavor. How many bowls are possible? Well, in a bowl, they're just going to go around, and there's no first, second, and third. There's just like 3 scoops in there. So since there's no order, this particular one is a combination. We have 31 and 3. I remember when I was a kid actually counting the different ice cream flavors at Baskin-Robbins, and I was really disturbed anytime I went in and they didn't have exactly 31. I guess that was the math in me coming out even when I was a little kid. So this is not too hard, but please send me any question you have. Use that Ask the Instructor if you get stuck, or send me an email. That finishes up this lesson. Thanks.